Now we are going to solve this exponential equation. So we will proceed in the routine fashion. That is, what we would do first is that we will try to isolate x. So in that order, let's just go ahead and try to isolate x. I think that's the best in simple language. Okay, so we have 4 to the x plus 2 equals 8. And here situation is fortunate. Looks like we would be able to get an exact solution because both of these, 4 as well as 8, are powers on 2. So what we have is this, that is here 4 is the second power on 2. Let me just write it slightly differently. I'm sorry. Okay, so let's just write 4 as 2 to the power 2. Okay, and that to the power x plus 2. All right, and then 8 is 2 cubed, right? Okay, now you know this, that exponential is a 1-1 function. So if I have two powers on the same base, the powers would have to be the same. So what I'm doing is, here I have power on a power, so the powers will multiply, or exponent of an exponent. Exponents just multiply, and here I put a wrong symbol. Let me change that. And on the right hand side I have 2 to the third. Now we shall use the 1-1 property of exponential function. So 2x plus 4 has to equal 3, which means 2x is -1, and that means, x equals -1/2. So let's quickly check our answer by substituting this back into the equation. So we have, this is the equation we want to verify. So we will go ahead and substitute -1/2 in here. Okay, so what do we get? 2 minus 1/2 would be what? 3/2, right? 2 minus 1/2, take common denominator, you get 3/2, and that equals 11. And now you have, what would you have here? You just have the cube on square root of 2, right? Sorry, square root of 4 I meant. Okay, because 4 to the 1/2 would be 2, and that cuts. And so if you look at that, then what we have is square root of 4 is 2, 2 to the third is 8, plus 3 equals 11. And let's just verify. Yeah, this is correct. So we got this solution correct. All right.